We're going? All right. All right, so I think today will be the last lecture on our I'll call it pure mathematical vectors. And up to this point in time, as a quick review, what was step one?
Vx equals v times cos
We
theta.
do the components. Vx equals v cosine theta. Vy equals v sine theta. All right. Step two,
Rx is
you sum up. And what does that give you?
That gives you the x component for the resulting vector.
Right. It gives Rx is the sum of all of the x components. Ry is the sum of all of the y components. What was the third one? Pythagorean theorem. And what does that give you? R, which is what part of the that gives us the magnitude. So this is R equals the square root of our Rx squared plus our Ry squared. And remember on this one, we just take the positive value of it. And then, what was our step 4?
theta equals arctan.
It was the angle, and it was the arctangent, and it is always Ry over Rx. And this is where, I want to make sure you know that's an X. Then this is where we had a little bit of an issue. All right? And this is where we're going to elaborate today to finish this off. We mentioned this whole process is super easy to break down into steps. So you can program it into a calculating device so that you can just enter a Vx or a V and a theta and another V and a theta and tell it to add it, and it'll do all this like behind the scenes. So if anybody goes to your calculator and learns how to enter vectors in their polar coordinates, and then you just tell the calculator, we'll add these two together, and it just spits out the answer for you. You don't see it, but it has done all of this behind the scenes because this is the way you do it. The last step is the one where things can go a little astray. Correct. Because when I believe we had our discussion about, in math, they talk about y being a function of x, and then if you were to do an inverse function, it kind of like is supposed to undo what the main function does. But there is a problem with trigonometric functions because they fail which test? The horizontal line test. So it's kind of like, you could say it's a little bit like square rooting, because when you say, what's -3 as a value squared, your calculator will give you 9. But then when you say, give me the square root of my answer, it won't give you the -3 back, it will give you the 3. Because the people who programmed the calculator had to deal with, well, when we take a square root, technically it could be positive or negative. How are we going to know which one? And the truth is, they can't. So they had to make a decision, and so they said, well, most of the time, people are just going to want the positive value, so by default, all square roots will be positive numbers when our calculator does its thing. So they had to make a similar decision when it came to your arc trigonometric functions. Because they fail the horizontal line test, when it came to doing an arc calculation, they had to limit where they express their angles. So the easy one to follow would be the idea of the tangent of 45 degrees. Because technically the tangent of 45 degrees, when you plot it like out in the unit circle, you get it being 1 over 1. And so your tangent value is 1. But you can also get a tangent value of 1 down at 225 degrees. But you get it for a different reason, because there it is a negative 1 over a negative 1. So when you go to your calculator and say, well, I'd like the arctangent of 1, it doesn't know the difference between the two. You know, if you wanted to write a program where it would say, you know, tell me how are you getting your 1? Positive 1 over positive 1 or negative 1 over negative 1, then it might be able to do something about it, but we don't do that with calculators. So this is where we are going to make an adjustment for you here, all right? And this does depend on what quadrant you're in. Okay? So if we go here, here's 1, here's 2, here's 3, here's 4. If you are in the first quadrant and you need to do an arctangent, do you have a problem with anything? No. It will give you exactly the number of degrees that you need. So, you don't add anything. Now, when people go, well, how am I going to know that? How are you going to know you're in the first quadrant?
By your x and y values, they're both positive.
Right here. What's going to be your sign pattern between these two if you're in the first quadrant? Positive, positive. Okay. There are times that sometimes I tell people, if you really want to make your work justified, when you get to this step, you put like a plus plus. If you're doing this, because that indicates to somebody that you understand that these two are positive, and that means your answer lies in the first quadrant. Okay. Now for the second and third quadrant, let's start with the second. My answer is over here. That's a quadrant that my calculator, it was programmed, it will not give me. Which angle will it give me?
It'll give you an angle in quadrant 4.
It will give you this one in quadrant 4, and how will it express it?
Negative.
It will give you a negative angle. So if I want this angle, what do I do with the number that my calculator gives me?
Add 180.
You add 180 degrees, and you got the right answer. Okay, now I'm not going to write that down quite yet, because if we go to the third quadrant, if I point over here, that's in a quadrant that it won't give me the actual number of degrees, because remember, what I want is all the way around 0 to 360. What will it give you?
Something in quadrant 1.
It will give you this in quadrant 1, which will be a positive angle. So what would you do with that in order to get the angle that you want?
Add 180.
You'd add 180. So for quadrants 2 and 3, the final step is both the same. You add 180 degrees. But the difference is, if you're in quadrant 2, what you'll get when you do this step will be a negative number of degrees, and then you add your 180 to that. So you'll end up with a number between 90 and 180. And if you're in the third quadrant, you'll get a positive number of degrees between 0 and 90, and then the adding 180 gets you from the 180 to the 270. Okay? For quadrant 4, now I can erase this, and we'll just draw this as, that's my answer, and what I want is this. What will it give me?
Negative 8.
It will give me this as a negative angle. So if I want the 0 to 360, what do I do with the number that it gives me?
Add 360.
You add 360. Okay? So that's the last little step here. So everything you need to do a straight up add a bunch of vectors for me, it's all right here. Now when we get into the physics application, you'll have some twists thrown at you because it won't be as straightforward like here's a bunch of this, work your way through here and get to some final answer and you're done. They'll be like, well, I'll give you this and I'll give you everything here but one and you have to figure out what's missing, or they'll give you a situation where you have to use these principles in order to figure out something about the situation. And this is where I can't emphasize enough that when you do a vector problem, you know, for people to go, I got it all visualized. You got to get a picture that justifies what you're doing as part of that problem. Okay? If all I see is numbers, you're not going to get full credit because somebody is not going to look at that work and say, oh, they must understand, you know, because the truth is, like doing these vector problems, I know people who can mechanically go through this because these are just rigid steps, but as soon as I throw them a twist on it, they're screwed. So this is the base that you build from, but each problem in the physics world can apply these in slightly different ways. And so just memorizing this really isn't, you know, the ultimate, but if you can do this solidly, when you get weird situations thrown at you, you are going to use these principles in order to figure out something about a problem. And that's where we're kind of headed. So, what's your assignment now? Your assignment is to do these three problems now. Again, but this time you're going to do them mathematically. So you don't need a protractor, you don't need a ruler. And the beautiful part is, what have you already done for everything? You've already done step one. So basically, what I need you to do, and this will be on a blank piece of paper, when you go to do D plus G, you need to show me in your work, you already have these values and you're going to hand that in with the work, but what you're going to need to do is show me this step, and when you do this step, I would like to see the processing of it. So when someone does D plus G and they just say, my Rx is this number and that's all you give me, you won't be getting full credit on that one. I literally want to see you say D, your Rx is going to be one, you don't have to give me the Dx plus Gx, but I need to see the two numbers that you're combining from your master list to get your Rx value. Okay, so I'll leave it at that. I was going to throw one more on there, but I'm not. So your assignment to be working on, like outside of class, unless we have some dead time in here, is to do these three problems now mathematically on a piece of paper. When you get to this step, be sure there is some reference in your work that shows me you understand what quadrant your Rx and your Ry point into, or your overall resultant points into, and you can do that with signs up here. Sometimes I have people actually do quick little sketches, like if this is positive and this is negative, I see an arrow over right, an arrow down, points down and to the right, and that means fourth quadrant, and then in their math, I see the plus 360.
Can we just say, like, for example, if something's in the third quadrant, just say like Rx and Ry are negative?
You could, one other thing that I occasionally see, because, and I think this is a quicker way to do this, since they define the quadrants usually with Roman numerals, when you get to this step, just put a little Roman numeral by your setup here, and that will indicate, that'll be interpreted like which quadrant is your answer pointing in, so that you would then, I would then see the correct adjustment for your angle that you would get on your calculator.
Don't you have our sheets that we did.
If I still have your sheet with all of the breakdowns, I'll get those back to you. Because I know when you finished them, I said if you didn't were afraid of losing them, you could give them to me. So I'll look through here and give any back. Although, looking in my period 2 folder, I don't have any.
Is that the vector?
That was the vector resolution
You didn't
assignment.
collect them on Friday.
What?
You didn't collect any of them.
No, because this is what we were going to have to do with this anyway. Okay.
Do you still want those at some point?
At some point.